This conference will now be recorded.
Good morning to one and all present here. So, Loyola Institute of Technology welcomes you all for this webinar on data science and its applications. It's my privilege to welcome and introduce our resource person, Mr. Dilip Muralidharan. He is a seasoned education professional working in the IT industry with 18 years of experience. He is a seasoned consultant in the education and professional delivery space. Currently, he is working as a senior technical instructor in Splunk, Chennai, which is the world's largest big data analytics company. He is a Dale Carnegie certified instructor and has delivered on-site training and consulting services to clients in India, Southeast Asia, Africa, North America, and UK. So I'm very happy to welcome you, sir, and thanks for accepting our request for this webinar. And before starting our session, I want to convey some instruction to the participants. So kindly all of you mute your microphone and turn off your video during the session. And you can post your questions in the chat box that will be answered by the resource person at the end of the session. And feedback link also will be posted in the chat box at the end of the session. And you can fill it and you can get your e-certificate immediately. So on behalf of LIT, Loyola Institute of Technology, once again, welcome you all for this webinar, and I hope this webinar will be very helpful to you. So now I hand over the session to our resource person, Mr. Dilip Muralidharan.
Thank you, ma'am. Good morning, everyone. Am I audible to everyone? Hopefully I am, and everyone can hear me loud and clear. Okay, excellent. Well, firstly, before getting started, a sincere vote of thanks to the organizers of this meeting, and also a sincere vote of thanks to the staff and management of Loyola Institute of Technology for putting this session together. And last but not the least, thanks to ICT Academy for organizing this session. My name is Dilip. I am a senior technical instructor, and I work for a company called Splunk. Splunk is arguably the biggest data analytics company in the market right now. And what Splunk does is Splunk works in the field of data science. We have a big data analytics software, and that big data analytics software, Splunk, is available on premises. It's also available on the cloud as well, whether it's going to be a private cloud or a public cloud or a third-party cloud, right? And we also work on several modules on top of our big data analytics platform. Namely, we have a machine learning add-on or a machine learning platform with which we can implement any functionality to the tune of artificial intelligence, implement neural networks, and we've got customers all over the world. We've got about 70,000 customers. Well, that was 2-3 years ago. Pretty sure we've got more customers now. But we've got customers all around the world. So I'm going to go ahead and I'm going to talk about data science and its applications today. So the lecture is going to be about 50 minutes long, and we're going to have a 10-minute Q&A, right? So I'll try and see if I can keep it to 45 minutes so we have a little more time for Q&A. But 45 to 50 minutes is the approximate amount of time that we are going to be spending. Now, a little bit of history before I move in. I come from an IT background. I've been in the IT industry for almost 18 years right now. I started in the early 2000s, and I've been in the tech industry for close to 18 years now, and I've also been in the education and consulting section of the business for almost 12 years right now. So I've been working in the field of enterprise software. I worked on GPS fleet management systems. For example, in the past, I worked for a company called Trimble Navigation, which is basically a GPS-based fleet management system company. I've also worked for companies like, for example, Computer Associates, right? So Computer Associates, again, Computer Associates is a very old enterprise software company, and I used to work on the storage and the recovery management portion of the business. I work with Convergys mainly on Microsoft Windows desktop and server-side tech support. I work for EMC, which is essentially a hardware company, but I used to work for the software side of the business. So I used to work on enterprise content management on products like Documentum, Captiva, SourceOne, Document Sciences, etc. And ultimately, I moved to Splunk about 4 years ago. So today's subject is going to be on the field of data science, right? So that's basically what we're going to look at. So let's go ahead and let's look at data science and its applications. So we are first going to talk about what data science is, and then what we're going to do is we're going to talk about what are all the applications for data science in business. And I'm going to try and show you maybe one or two demos. I always believe in demonstrating something while I speak. So in accordance with that philosophy, I'm going to go ahead and I'm going to try and show a bunch of demos so that you can actually understand, what's going on in here, and maybe put things into perspective. All right. So let's talk about data science. What exactly is data science? Well, let's follow a structured learning approach here, right? So I'm going to go open a browser session here. And in this browser session, I'm going to open up Wikipedia. So let's say, can I Google for data science? Let's see what Wikipedia or Google in general brings forward. Okay, let's go with Wikipedia here and see, what Wikipedia says about data science. So Wikipedia says data science is an interdisciplinary field, right? So what does interdisciplinary mean? Essentially, it's nothing but it's a combination of multiple academic disciplines into one activity, right? So we use scientific methods, we use business processes, algorithms, and different software and hardware systems to extract knowledge and insights from any structured or unstructured data. So data science is related to data mining, deep learning, and big data. So let's get back to our lecture material here, right? And let's talk about what we've just read about the definition of data science on the Wikipedia page, right? So data science is a very large field. I would say data science is actually an umbrella word for a lot of different things, right? So data science is a field that deals with big data primarily, right? So primarily we deal with big data, and that brings us again to the question of what exactly big data is. So let's go look at the definition of big data here. So what is big data? Big data is nothing but it's a field that treats ways to analyze, systematically extract information from, or otherwise deal with data sets that are too large or complex to be dealt with a traditional data processing application software, right? So let's go back to our lecture material here. So what's big data here? Big data is, in very simple layman terminologies, the field of studying data which is either too large for traditional data processing applications, right? Or it could be too complex for traditional data processing applications. So I would like to, open the Q&A here and ask some questions. Can anybody give me an example for, a traditional data processing application? Give me an example for any data processing application. What kind of data processing applications do you know? Give me an example. You can answer in the chat window, or you can also unmute and speak up. But if you unmute and speak, go right back to mute after speaking up so that there is no background noise from where you are. So give me an example for data processing applications. Any data processing applications. Doesn't matter, what kind of data processing application. Syed Ibrahim Sage, Google search is a data processing application. Okay. Yogan and Selvaraj, DevOps, Jenkins, Kafuka. Okay. Meghna says spreadsheets. Okay, spreadsheets is a great example for data processing applications. Okay, what else? Anybody else? Facebook is a data processing applications. Okay, I can sort of see where you're coming from. Database programs, says Meghna. Okay, again, very good examples from Meghna. Database programs are excellent examples for data processing applications, right? So what exactly is a traditional data processing application? Well, a traditional data processing application is essentially nothing but, okay, bunch of more examples there. Chetan says cloud computing, personal finance software, says Meghna. Syed says sorting search. Yoganand says ETL tools. Sentiment analysis. Okay, right. So those are all examples for data processing applications, right? Traditional data processing, weather forecasting, customer data analysis. Well, I'm merely talking about data processing applications. I'm not talking about use cases, right? So we're not discussing use cases. We're only discussing applications. So I think Meghna has given a lot of good examples here. So let's work with what she's given us, right? So what are all some of the traditional, data processing applications? Well, there's plenty of data processing applications available. In fact, I'm pretty sure most of you are using quite a bit of data processing applications already. So for example, quite a lot of you might be using this tool called, Microsoft Word or Microsoft Excel or Microsoft PowerPoint. These are all actually data processing tools. So they're all a part of the Microsoft Office suite, right? And that's basically what a traditional data processing application is. For that matter, even relational database management systems like Microsoft SQL Server, right? Or for that matter, Oracle or DB2 or Sybase, these are all traditional data processing applications. Now, traditional data processing applications cannot process very large quantities of data. They have a scalability issue, right? Or they cannot process very complex pieces of data as well. All right. So what do I mean by that? Well, very large pieces of data are potentially pieces of data that we're talking about that that can measure in several hundreds of gigabytes or maybe even terabytes or petabytes. right? That's pretty normal. About 15 years ago, when I started working in the field of enterprise software, customers used to typically buy licenses for about 10 gigs, 15 gigs, 20 gigs, or 50 gigs worth of storage. But today, customers don't buy storage in gigabytes. Customers buy storage in megabytes, sorry, in terabytes, right? So that's where data storage is going, right? So if you think about it, right, if you actually go ahead and think about it, right, every day the amount of data that you're handling, and more importantly the complexity of the data that you're handling, keeps on ever increasing, right? And that's where big data comes into the picture. Now, when big data comes into the picture, machine learning was an obvious eventuality, right? When it comes to big data. So, what exactly is machine learning? Well, you know what? Let's go ahead and let's search for machine learning and understand what exactly machine learning is. All right, machine learning or ML is the study of computer algorithms that improve automatically through experience. It's been a subset of artificial intelligence. Machine learning algorithms can build a mathematical model based on sample data, also known as training data, in order to make predictions and decisions without being explicitly programmed to do so. So that's a fantastic definition for machine learning, right? So machine learning is nothing but we use an algorithm, specifically a mathematical or a statistical algorithm, and that statistical algorithm or mathematical algorithm is in turn used on a piece of training data. Now that training data will be identical to the data that we would find on on a production environment, right? So that training data is available on a production environment. So we take a sample of the training data, we train that data using an algorithm. And once that algorithm has understood the data, then what we can do is we can use all the arguments and the vectors available from the mathematical algorithm to actually run on the production data. And from the production data, we can actually try and understand what's going on with the production environment. So we'll try and understand what's going on with that piece of data, and we'll be able to make predictions in the future as to what kind of things are going to happen in the future. So if I think about it, what kind of predictions I can make, there's a wide variety of predictions that I can actually make. So what kind of predictions can I actually make? Well, I can make a lot of predictions along the lines of, let's say, for example, I can predict when I am going to have, excessive sales. So sales prediction models are very, very important in the world of machine learning. I can predict the amount of demand for a particular product that's going to come up in the market. I can also predict any bottlenecks that I can have potentially in some sort of fulfillment scenario for a sale, right? So machine learning is usually a logic-based approach, right? We do a lot of pattern analysis or a pattern-based approach as well, right? And we go ahead and we ensure that the mathematical model is consistent with training and with understanding the data, right? Now, in the world of data science, artificial intelligence is the buzzword right now, right? So the question obviously becomes, what exactly is artificial intelligence? Well, artificial intelligence is nothing but it is the world of building you know, let's actually go look at the example, the definition for artificial intelligence. So in the world of computer science, AI or artificial intelligence, right, is nothing but the actual intelligence that could be demonstrated by computers or machines, right? So the idea is to mimic the natural intelligence that is displayed by humans or animals, right? So essentially, artificial intelligence is a field of study where we use machine learning to train a piece of data to be self-aware or an application to be self-aware. So you can actually say that machine learning is actually a subset of artificial intelligence. So in the field of artificial intelligence, what exactly do you do? Well, in the field of artificial intelligence, we actually build something called as a neural network, an artificial neural network. So what exactly is an artificial neural network? Well, those are again nothing but computing systems, right, that are inspired by actual biological neural networks that you will find in animal brains. So neural networks are nothing but they're containers that learn to perform tasks based on repetitive activity of a particular task, and also based on the rules for how exactly that task needs to be executed, right? That's what a neural network is in the field of computer science. Now, usually speaking, what we do is when we work with big data, we work on data models. We build a lot of data models. So question, what exactly is a data model? Well, a data model essentially at the end of the day is nothing but you are going to build a data set or a bunch of data set and put all of them together in a container so that that data can be used to extract intelligence or gain knowledge from that particular subset or the entire set of data. That's what a data model is. Now, one of the biggest things in the field of data science is predictive analytics. In fact, I will try and show you, right, what exactly is predictive analytics. I'll try and show you a demo. One of the things that I want to show you today is actually a demo that is going to deal with predictive analytics. So we'll see how predictive analytics works in the real world environment. All right. So without further ado, let's move on and let's talk about the applications for data science. So what exactly are the applications for data science on a day-to-day basis? Well, the first example is transaction monitoring. Now, what do I mean by transaction monitoring? Well, let's actually ask a couple of people if someone has an idea as to what transaction monitoring is. Please put your answers in the chat window. What do you understand by the term transaction monitoring? What do you understand by transaction monitoring? Have you come across this terminology before? Anybody has any idea on what transaction monitoring is? Blockchain logistics, no. I'm asking for what transaction monitoring is. I'm not asking for buzzwords. I'm looking for a simple definition of what transaction monitoring is. Maintaining a network, not really. Current customer information, not really. Rajender Kalwala says customer transaction. Okay, that's somewhere. Excellent. Sankareshwari says monitoring to avoid fraudulent. Okay. Rashma says type of monitoring access, balance, and transactions in banking. Excellent example, Rashma. Syed Ibrahim says payment gateway. Okay. Bhargavi says electronic funds transfer. Okay, we got a few examples right there, so let's work with those examples. I think a bunch of people have been correct. So I think Rajender, Sankareshwari, and Reshma have all made some valid commentary. Transaction monitoring is nothing but the monitoring of any transaction. Now, it need not necessarily be customer transaction, right? But it could be any transaction, could be banking transactions. It could also be a process transaction that is running. It could also be the completion of a manufacturing activity of sorts, right? So question, why would we want to do transaction monitoring? Well, transaction monitoring is very, very critical because transaction monitoring will allow us to understand the business better, right? If we monitor transactions, right, then we'll get to understand what is the behavior of the user or the customer, right? That, in a sense, will help business sell better or target products or sales better, right? So transaction monitoring also allows us to prevent any fraudulent transactions or fraudulent attempts at transactions, right? So that's, what transaction monitoring is. Now, let me ask a question here. Has anybody here, shopped online on Amazon or Flipkart or, Snapdeal or any of the online platforms? And have you been in a situation where you entered your credit card information or your debit card information or bank account information? The money was taken from your account, but the sales did not go through. The actual sales transaction failed. All right. So if the transaction failed, okay, so question, what did you do to get your money back? What did you have to do to get your money back? Or to make the sales transaction become successful, whatever it is. How did you get your money back? What did you have to do in order for you to get your money back from, Amazon or Snapdeal or Flipkart or whatever? What exactly? Raise a dispute. Okay, nothing. I didn't do anything. Okay, wow, that's difficult. Automatic refund. Okay, contacting bank. I wrote a complaint and the money was reverted. Okay, all right. So we've got a bunch of examples there, right? So let's look at some of the examples. Syed says automatic refund, and Chetan Kumar says contacting the bank. Virana says customer complaint. Now, those are all classic examples for transaction monitoring, right? Now, every sale is going to be a transaction in any system, right? And what that means is that when you go ahead and when you raise an issue with a transaction, that transaction can be reverted if that transaction is properly monitored in the environment. All right. So let's talk about, the next use case for applications for data science. Predictive analytics, another use case, right? What is predictive analytics? Predictive analytics is the field of trying to predict what exactly is the requirement or what exactly is going to be the activity in the future. All right, that is what predictive analytics is all about, right? So predictive analytics is all about using machine learning and artificial intelligence and trying to understand the current pattern and behavior of a data set and then trying to predict how that data set is going to behave in the near future, usually in the near future, or sometimes into the far future, right? So that's what predictive analytics is. In fact, I'm going to show you an example with predictive analytics, right? So, let me check if my machine is up and running. Yeah, it is. Okay. So I'll show you an example for predictive analytics in some time. So what other applications exist for data science? Well, media and entertainment is a huge use case, right? So, okay, so give me some examples of media or entertainment content that you consume on a daily basis. What kind of entertainment do you consume on a daily basis? Television, radio, what else? What other kind of entertainment do you consume apart from the usual television or radio? Music, Facebook, YouTube, Twitter, okay, mobile, infotainment, Netflix, excellent example, Netflix, Instagram, newspaper, news, okay, all right. Any other examples? Amazon Prime, okay, Twitter again. What else? Magazines, okay, what else? Hotstar, books, WhatsApp, excellent example. WhatsApp is probably the most entertaining tool out there, I would assume. Well, we could have said TikTok, but thankfully TikTok is banned now. Telegram, Kpis, okay. So those are all plenty of examples, right? So data science plays a role in every single one of those platforms. If you think it doesn't, you have to rethink, because it most certainly does, right? So every one of the modern media algorithm, right, is essentially at the end of the day powered by data science. Specifically, it is powered by machine learning, right? So that machine learning algorithm, right, is essentially going to use your past behavior and your search activity to predict what kind of content you might like, right? So data science is one of the biggest proponents when it comes to the use case for media and entertainment. Healthcare, diagnostics and treatment, which is actually an excellent example, right? So those are the applications for data science. So today, you've got a lot of devices that are available, right? For example, I'm not sure how many of you are aware, but there's actually a device called as a pulse oximeter. This is not something new. It's been around for quite some time now. Let me look at this device here. This is actually a pretty useful device, right? So this is a pulse oximeter. I actually have like one of these, pulse oximeters with me. So what does a pulse oximeter do? It's very useful, especially in terms of a pandemic where infections are, plenty. So it's simply put, it's a lightweight device that is used to monitor the amount of oxygen that is carried in the body, right? So you can just clip it to your fingertip. So, it's like a clip. You just clip it to your fingertip right here, and it'll give you a reading. It'll essentially give you a reading about what exactly is your heartbeat, and it'll also give you examples about, it'll give you information about what is the oxygen content in your blood, right? It's a pretty useful device, right? So if you're unfortunate enough to feel very sick, especially get infected with a flu like COVID-19 or the general influenza or something like that, then generally speaking, a pulse oximeter is what is used by medical professionals to detect what's happening with your, blood oxygen level in your body. Now, that pulse oximeter, the very small device, it actually contains some minuscule data algorithms that are able to predict, right, with a great level of accuracy, what exactly is your heartbeat and also what is the oxygen concentration levels in your body, right? So that's a classic example of use of data science for healthcare, right? Okay. Um, Question: how many of you here? Well, you might have not bought personal. You might have not purchased this personally, but maybe if you're a student, your parent has. How many of you here in class? How many of your families have health insurance? Anybody's got health insurance? Yes, no, maybe. Okay, give me an approximate number. I don't need an exact number. Give me an approximate number as to how much you pay on a yearly basis for your family's health insurance. Just give me an approximate number of the amount of money. Okay, Virana says 9,500 for the entire family. Wow, that's a great deal. 10,000, 15,000. Okay, 15,000. Okay, 10,000, 9,500. 16,000. Okay. 20,000. 1 lakh. 20,000. Okay. Now, the reason why I asked this question is because you see, multiple people here have health insurance, right? But do you notice that nobody pays the same premium? Everybody ends up paying different premiums. One person is paying 10,000, another person is paying 1 lakh. One person is paying 9,500, another family is paying 16,000 or 20,000. So the premium for health insurance for different families differ radically. How did that come about to be? That came about to be because there's a lot of data science at work in the background. Your age, your health condition, your previous instances of illness and health history, right? Your previous hospitalization records, your family health history, the place that you live in, right? The kind of environment that you are in, right? The kind of lifestyle that you practice, right? Whether you are a vegetarian, whether you consume meat, and if you consume meat, do you consume the right amount of meat or excessive amounts of meat? Do you work out, exercise, right? Are you healthy, right? Do you smoke? Do you drink, right? Do you consume excessive sugar? These are all variable factors that go into the data analytics that is going to predict the amount of insurance that you pay, right? Well, to be fair, it also depends upon what kind of policy you're taking. So maybe the folks who take policies that cost less are taking a very basic insurance policy, and maybe the folks who are paying a lot of money, right, are taking a comprehensive insurance policies. It might also be the case that there might be more members in their family, right? So all of that is quite well possible. But you see how data science determines the output of the health insurance here, right? Now another use case, right, for data science is IT security. In fact, this is probably the most widely used use case when it comes to data science today. When it comes to IT security, data science is fundamentally the driving factor to define how exactly things are going to behave, right? So that's basically an excellent example for data science. Almost every other application that you run, for example, any antivirus applications that you run, they run on the basis of data science. I mean, they've been running on the basis of data science, not for now. They've been running on the basis of data science for decades. I remember my first computer was probably the first time I started using a computer regularly was way back in 1995, I think. So even there, right? You know, the design, the fundamental design of antivirus applications have actually not changed much at all. I can show you an example. This is, a Kaspersky antivirus software. And what this does is you see this database update here. Every time I update the database, we're actually downloading nothing but we're downloading data models and data set from the Kaspersky servers, right? So those data models, those data sets come from the Kaspersky servers, and those data sets or those data models, right, are going to use, they're going to be used to train the antivirus application in trying to identify newer types of malware so that those types of malware can be detected. This is actually a very, very good use case for IT security purposes here, right? So we use a lot of different types of algorithms when it comes to machine learning in the field of data science. So I mean, these are not the only algorithms we use, but we use a bunch of algorithms. We use linear regression, right, which is for simple regular repeating patterns. We use random forester, which is for training complex unnormalized data. We use a gradient booster, which is complex data with patterns. That's what we use gradient booster algorithms for, right? And we use logistic regression, which is for service severity prediction, right? So those are all the different types of algorithms, but those are not the only types of algorithms that we use, right? Okay, there's a question here from Dr. S. Bhagavi. What are the security issues in data science? Well, the security issues in data science are plenty. I mean, your security issues are dependent upon your deployment. So it depends upon what kind of application you're deploying. So you could have security issues anywhere. You could have security issues in the front end. You could have security issues in the middle tier. You could have security issues in the backend. So it could be something as simple as not configuring encryption, right? All the way to something as complex as one of your dependency software, right? Being a dependency software having a vulnerability, and maybe that vulnerability could be exploited, right? So there are plenty of security issues in data science, and just like there are plenty of security issues in pretty much any piece of application you can deploy. So without further ado, I'm going to show you two different examples for data science. I'm going to show you a predictive analytics example using Splunk IT Service Intelligence. Splunk IT Service Intelligence is actually an IT service management product. And I'm also going to use Splunk to demo a sales analytics for e-commerce, right? So let me get into my machine here and let me show you how data science helps determine IT security. So we were just asked a question, what are the security issues in data science? Guess what? We're using data science to actually fix security issues here. So what you have in front of you is nothing but it's a dashboard. It's just a service management dashboard, IT service management dashboard. All right. So I have three services that I'm monitoring. I have an online sales service, which is for monitoring online sales. I have a support web farm service, which is for monitoring a support team. I have a storefront web farm service, which is for monitoring the servers that are responsible for the online sales over here, right? So that's what I'm going to do. Now, if I go click and select any service, I'll find KPIs. So what exactly are KPIs? Well, KPIs are nothing but KPIs are just your, hang on one second here. I'm going to have to minimize my screen here. Okay, now I can. So KPIs are nothing but my KPIs are key performance indicators. That's what KPIs are. So these KPIs will contribute to the health score of this service, right? So right now, my online sales is at 52.5% efficiency. My support web farm is at 70% efficiency, and my storefront web farm is at 76.9% efficiency. Now, what I am going to do here is pretty simple, right? I'm going to go and check out a predictive analytics. What is predictive analytics? Well, I'm going to try and predict what's going to be the health score of the online sales service in the next 30 minutes. Right now, the service health score of online sales service is about 50%. But my question is, what will it be in the next 30 minutes? Well, I can use predictive analytics, so I can choose, for example, online sales as a service here. I already have a trained algorithm. I already have a trained model here for the online sales service. So what is the trained model here? I have a linear regression model. If I choose linear regression, I'm going to run the mathematical algorithm in the backend on the online sales data, and I'm going to tell you what's going to be the percentage. It's going to be 54.49%. I can even click on cost analysis to look at the top 5 contributing KPIs, and I can even predict what's going to be the status of those KPIs within the next half an hour. That is within the next 30 minutes here. So you can see right now, my support, my online sales is at 64.2%, but in, half an hour, it's going to deteriorate to 54.49%. So the question is, can I only use linear regression? Can I use any other mathematical model here for my online sales service? Yes, I can, but I need to train it. So I'm going to go train this service. I'm going to edit this service here, and I'm going to train this service. So right now, I've got the online sales service. So I can choose regression. I've already done linear regression. I can do random forest regressor. Now look at the training data right here. The training and test data is a 70-30 split. What do I mean by that? Well, I'm just using 70% of the data to train the algorithm and 30% of the data to test the algorithm. So let me hit the train button. When I hit the train button, you can see I am creating a data model here. See that? I'm actually creating a data model. Now this data model is being trained for a 14-day period. Now this data model will take some time. It might take about half a minute to 2 minutes for this data model to run, right? We're gonna have to wait for this data model to run. Once this data model runs, then we will get to see, what's gonna happen. Okay, so random forester has completed running. I can train another data model, gradient boosting regressor, train that. So that model is also going to run. Again, this will take about half a minute to 2 minutes for this model to run. So let's sit and wait for this model to run, and we'll see how. Okay, I can also train the classification algorithm, which is a logistic regression, train that as well, right? So what I'm doing here is that I am using machine learning to implement some statistical algorithms here, right? So I'm going to hit the save button, and if I go and if I refresh this predictive analytics dashboard here, right, I now have access to a lot of different models. Let me choose gradient boosting regressor because that's the recommended model that best fits the data here. And look, it says 64.22%. What is the current health of the online sales? So right now online sales is at 82.1%, and it says in half an hour's time it's going to be 64.22%. That's how it's going to degrade to. All right, so that's basically how I can make use of predictive analytics. I can use predictive analytics for every service. I can use it for the storefront web farm, right? This might have a model. Oh, this doesn't have a model trained at all. So I can actually go to the storefront web farm here, right? So I can go to the storefront web farm and I can edit the storefront web farm service here. And I can train the storefront web farm service using algorithms as well. So I can choose regression, linear regression, train that, right? So I can train that algorithm as well with a new formula, with a new algorithm. So let me wait for this model to train. And once I train this model, I'll actually be able to see that predictive analytics at work.
पेपे नहीं करनी सीधी वेट तनीषा
Takes a little bit of time. Let me save this here. And when I save this here, look, if I go back to storefront web farm, I now have a model that will be available for me. See that? Linear regression. See that? So that's basically how I can use predictive analytics to predict what's going to happen in the near future, right? So that's one use case that I've just demonstrated for data science. Let's look at another use case here. We're going to look at a sales use case. I'm going to go into my search here. I'm going to bring up some sales data. I'm selling something online. I'm selling different video games online. So I'm going to do some programming here. Index equals to, all right. So this is basically my online sales data. So this is all the data. This is all the sales that I've had in the past 24 hours. Now, this is the kind of data. This is the kind of raw data that my servers will throw. I've indexed all of this data using Splunk, right? Now, my only question here is, how do I get this data to make sense for me? So basically what I want to do is I want a list of products that I've sold, the product categories, right, that I've sold. And I also want to know the total amount of revenue that I've made from each and every product, right? So how do I do that? Well, first I need to look at the purchase actions. So I'll choose purchase actions, use a key value combination pair. And I also have different success codes. So status code, this is all HTTP status code. 404 is file not found. 505 is internal server error, something like that. So let me choose 200 for successful purchases. Now it's a matter of running simple statistics on this. So I can simply say stats, sum of sale price by product name. And is there a category field here? Product category field here. Oh, wait, there is no product name here. I only have a product ID, I'm afraid. So let me choose product ID. Looks like I don't have sale price. Maybe I have price here. Oops. Let me check if I've got a price field. Looks like I might not have a price field. I might just have product category, item ID, product ID. Let me see if I've got a field here for the sales data here. Okay, this is the web server log, so obviously it doesn't have a price. So maybe what I will do is I will try and use something else here. Okay, let me try and see how much of sales went through which kind of different servers here, right? Stats list of product ID by host. So there you go. This server has sold all these different products. And this server, support 2 has sold this products. Support 3 has sold this products. Support 4, support 5, these are all servers that have sold different products. I can even get unique values here. See, these are all the unique products that have been sold across 5 different servers here. Well, actually 8 different servers over here. Now, what if I only want the, sales servers? I can just restrict that as well. There you go, 3 different servers. See that? That's what I get. So I can also put that in a chart command so that I can chart it out, give me the same results. I can even visualize this if I wanted to, right? So I can put that in a column chart or a value, I can say chart count. See that? So I can count the total amount of, different product IDs across different web servers here, right? Or I can count it across all the different servers, including my support servers here. I can put a bar chart, column chart. I can have a pie chart, right? I can pretty much do whatever I want to. I can also have a trellis visualization as well, where I can visualize the entire thing if I wanted to. Of course, trellis doesn't make sense here because I don't have comparative data here, right? So trellis makes absolutely no sense. So, that's another use case. This is a sales data that I'm using in order for me to predict, in order for me to analyze this sales data right here. What else can I do? I can also use data science for security purposes as well. Look at this episode review. I have another tool here for me to find out all the problems that exist in my environment. See, these are all problems right here. These are all support tickets that are open. I can open any support ticket. For example, this low conversion rate actually indicates that my sales conversion is very low, right? So that indicates a problem right here, right? So those are some of the ways in which I can use, data science, specifically machine learning and artificial intelligence, to understand the data that I have with me. So what are the future trends in data science? Well, I think artificial intelligence and neural networks is all the future. There's actually a new product called Neuralink, which is going to be in the market in a few years from now. The Neuralink is run by the same person who runs the CEO of Neuralink is the same person as the CEO of the electric car company, Tesla. You might be aware. So Neuralink is essentially, it's a chip that's implanted into the cerebral cortex to stimulate dead portions of the brain and interact with the brain directly. So some of the use cases for this product is actually reanimating activity to assist people with disabilities or even palliative care, right? So that's where data science is headed right now. So, and that's just one example. I can keep giving you several examples here. You might have read in the news about the drone warfare and how people are using drones for surveillance, especially the military and the intelligence services, right? So that's a classic use case for data science. If you ever buy a drone and if you ever fly a drone, drones essentially use machine learning to understand how exactly what is the wind speed, the drift, and adjust their position accordingly, and fly better. Right, almost any decent drone that you would buy in the market, like your DJI Phantom or whatever, all of those essentially make use of machine learning, right? So that brings us to the end of our discussion, right? A quick discussion on data science, its different applications, and two different demos as to how I can actually implement, machine learning and data science and artificial intelligence to get things done in the workplace. Now, what I would like to do is I would like to open up the session for Q&A. All right. So if you have any questions, please go ahead and put them in the chat window and I'll answer those questions. There are some questions already here. So what I'm going to do is I'm going to check those questions already. All right, so let's look at some of those questions. Sir, what are the software knowledge and skills required to enter into the data science field? Okay, that's one question. Another question is, how often should the data model be trained? There's another question about Python and R being, is it required for Python and R training for data science? Yes, Python or R language is essentially the best platform for data science right now. So you should ramp yourself up on Python and data science. The other question is about how often the data model needs to be retrained. Well, the data model will need to be retrained on a periodic basis. It depends upon how frequently your data changes. But remember, that can be automated. You can automate it using a simple script or something like a workload management, module, right? So let's see. Let's look at some additional questions. Does anyone need full knowledge of computer science to enter the field of data science? Well, if you want to be a statistician, no. But if you want to work in the field of data science, yes. You'll need to have a basic rudimentary understanding of how to use computers for sure. Okay, any other questions? Did I miss any questions here? If I missed some question, please repost it because the chat window keeps scrolling up. Data analysts and data scientists are the same. Yeah, pretty much. It's an interchangeable terminology these days. What is the future of data science after 5 years? Well, data science is essentially going to be the future of pretty much every product. There's not a single product in your household that does not use data science as a part of its functionality. If you have a smart TV in your house, it uses data science. If you have a refrigerator that you purchased in the last 2 years, it uses data science. The refrigerator collects information about which areas of the fridge are cold enough and not cold enough, and it actually focuses the compressor on the parts of the fridge which does not have which are warmer than other portions of the fridge. If you have a CCTV camera, that uses data science to automatically determine facial recognition in case you purchased facial recognition. How can data science be applied to vehicle management? Well, we have already started using data science for vehicle management. Have you ever heard of the immobilizer feature that's available in most cars? Well, immobilizers work on the basis of the the computer chip that that is available in most cars today. So computer chips will allow you to completely disable a car's engine by simply remotely making a complaint to the service center. So many higher end cars have, remote immobilizer chips. If you also have a GPS based tracking system for your car, you're already using data science to navigate your car. If your car has built-in, data science. Data science relate with sentiment analysis. Well, data science can be used for anything. So sentiment analysis could be one of those things that you could use data science for. Sir, how do I learn data science? What are the learning opportunities? Well, congratulations. You're living in 2020, Chetan. Go to YouTube, go to Twitter. There's plenty of blogs. I don't think you need to go to an institute. Start learning Python, start learning R, start downloading the free versions of software like Hadoop and Splunk and whatnot, and set them up on your laptop and start learning. Nobody's stopping you. When do you think should retain a model is dependent on data? Meghna, I'm not sure if that question is clear. I'm not sure what do you mean by when do you think should retain a model is dependent on data. I'm not sure if that question makes grammatical sense for me. Can you rephrase it? Is data science hard to understand? Any useful courses for data science? Data science is hard to understand. It's not a, I mean, like any field of computer science, it has its own level of complexity, but it's only hard to understand and boring if you're not interested. It's not hard to understand if you're genuinely interested in exploring and understanding data science. Which programming language is best for data science? Well, there's a lot of programming languages that are now used, but predominantly Python and R and Node.js and JavaScript are essentially the predominant, the predominant items there. Please send presentation and PPTs. I'll send the presentation to your coordinator, and then they can distribute it to you. Is it possible for recorded video of the session? I don't know. I think that's a question for the management. Meghna asks, does the format change? Does format change? Meghna, I'm not sure what that question is. I'm not sure what format you're talking about. So can you elaborate on that question? That question is a little bit. Okay, if we don't have any further questions, we can wrap up our session today with this. I will let the moderators take the call on that. I'm not sure. I don't see any questions, but if you have questions, you can of course post it on the chat window. If there are no further questions, I think we'll just wrap up today's session.
Thank you, sir.
You're welcome.
Thank you, sir. So now it's time for a vote of thanks. I request Dr. Pritidana Cyril, Head of the Department IT in Loyola Institute of Technology, to deliver the vote of thanks.
Thank you, ma'am. So I feel allied to propose this vote of thanks on behalf of Loyola Institute of Technology. Hope you all enjoyed this session. I am very glad to see the good response of faculties and students from various institutions. First, I thank all the participants for participating in the webinar during this current situation. I would like to thank our management for constant support, and I extend my heartfelt gratitude to our principal, Dr. Sujata Anand, for her motivation. A special thanks to Mr. Dilip Muralidharan for sharing his knowledge to make this session more interactive and lively. I'd like to thank my colleagues to make this program success. Once again, I thank all the participants for participating in the webinar on data science and its application. Stay home, stay safe. Thank you. Thank you all. So the feedback link is available in the chat